Hey everyone, welcome to another video. In this video, I'm going to go over some of the tips and the tricks that you can use to boost up your inference speed. And I'm going to go over one of the techniques that I use to do quantization for the models that I train for animal pose detections and just in general animal tracking. So without further ado, we can get some benefits even without quantizing by just using some of the tools that libraries like Ultralytics they provide. So image size reduction is number one thing that you can do to try to get some boost in speed uh, for processing per frame. Okay, so make sure that you're utilizing the image size that you used for training your model. If you want to reduce the image size so that it takes less time to process your image, then perhaps train your model on a smaller image size so that it's well suited for looking at reduced image sizes. um, there are also ranges within the configurations that you can set, and this goes more into fine tuning your training data and the training itself. But there are ranges that you can set. So you can set your range to be from 20% of 20% reduced size from your current set of images to all the way up to 110 percent of the size for your images in the training. So your model will see different variations of images in your training, and it will learn to predict on smaller sizes of images if you train it that way. The other way that you can get some boost in speed is by setting the the flag half to FP16s. But in other words, set it to true so that you are loading in a smaller size of your, or rather a quantized size of your model for doing inferences. So I'm going to actually go ahead and do this. I'm going to show you how you can quantize a pre-trained model or the YOLO architecture model that is used in IntegraPose, how you can take that and quantize it down to 4-bit Q4 quantization level. So stay tuned till the end. I'm going to walk you through this process. So the first thing is to download the repo, and you're going to unzip it. Wherever you unzip it, go into this folder called behavior annotation model training, and there's a environment configuration file. That's what I'm going to use to create an Anaconda environment. And just in case you need instructions to create the Anaconda environment, go down to prereqs like this, and you can copy this command and paste it in your environment, in your Anaconda prompt so that you can begin to create an environment. I'm going to walk you through this. The first things first, I'm going to copy this path and navigate in my Anaconda prompt to that folder, copy this command and paste it, and that is going to create an environment called IntegraPose. It's going to take a couple of minutes for me. My internet is slow, so I'm going to pause the OBS and then come back once the environment has been generated. All right, so the environment has been generated. I'm going to grab this command that says conda activate IntegraPose, and I'm going to paste it. And this time, instead of having a base inside of my parentheses, it says IntegraPose. Okay, so what this means is that the IntegraPose environment has been created. And now I'm going to show you that you have to install NVIDIA TensorRT. This is a requirement before you can begin to quantize anything. And this precisely works for NVIDIA GPUs. They have added support for the FP8 quantization, which is what I'm going to be doing. And these models they're crazy fast. You lose a little bit of precision, from going from 32 quantized model to an 8 quantized model. You lose some precision, but overall the speed and it is fast. Okay, so I'm going to leave this up to you guys to do. Basically, when you download the version that is compatible with yours. So here, for example, mine was Windows 10 and 11, CUDA version 12. Okay, so I clicked on this, it downloaded the zip file. I have unzipped it over here. Inside of this folder, I'm going to navigate over to Python, and I'm going to use pip install to install the files that I need. I've already created myself some notes. And before I move on, I'm going to highlight a few things for you guys so you have an easier time. So inside of this Python file, you're going to have to pick one of these to install in the first run. In the second run, you're going to have to install one of these. And in the third run, you're going to have to install one of these. So all three of these have to be installed. Just depends on which version you're going to be installing. So you're going to need dispatch, you're going to need lean, you're going to need the TensorRT itself. Okay, so just make sure you have the correct version selected for compatibility with your own CUDA and your GPU. So I have already mine because I've done this before. So I'm just going to navigate over to this directory. I'm now in that Python folder like I show here. I'm in this folder and I'm going to copy these lines one by one. Okay, and these are the ones that work for my GPU. All right, so all three of these are done. I'm going to reinstall Ultralytics and upgrade it at the same time. By the way, I will put some of these instructions in the video description, but not all of these are going to be applicable for everyone. So just pay attention to what version CUDA that you have and what version of the TensorRT that is compatible with your CUDA version and your GPU. And then from here, you'll have to select. So in my case, for example, I'm using 10.12. And for 10.12, the CP312 works for my GPU. CP312. So in the dispatch, CP312 works, and in the lean, CP312 works, and then in the tensor itself, CP312 works. So this is for my GPU. You're going to have to figure out for your own GPU what works. That's going to require a little bit of trial and error, but once you get it installed, you basically don't have to reinstall it unless you delete the environment. Okay, so Ultralytics got updated. I'm going to go ahead and update these next few libraries one by one. They should already be up to date, but I'm going to just recheck this. Like for example, here I didn't have the onnx runtime-gpu installed. Okay, so all of that is set up. Going to install Pytorch for my CUDA version. For the Pytorch, you can just Google Pytorch like this and navigate over down here. You can find the compatible version for your GPU. This will take a few minutes, so I'm going to skip ahead a little bit. Okay, so the Pytorch is done installing. Now we can move on to doing the quantization. So if you have your model trained already, So for example, if you train a model through IntegraPose, it's going to get generated and be saved in a folder called weights. So inside of that folder, you're going to see two models. One is going to be the last run of the epoch. The other one is going to be the best model. You will also see some of these other files inside of the weights folder. So what I've done is I've taken that weights folder and the YAML file that was used for training that model and navigated over to my workshop video data file and pasted those two here. I also have the video that I'm going to be using for testing the original model and its speed against the quantized model's speed. So that way I get a sort of a benchmark of what's the difference between the quantized speed and the original model speed. I'm going to navigate over to my weights folder and I'm going to set that as my working directory. So inside of this, what I need to type in YOLO export. Model is going to be my best.pt. That's the name of the model here. This thing is called best.pt. You can name it whatever you like. Format is going to be engine. I'm doing int8 compression, setting that to be true. Make sure this true here is the T is capital. For that is the capital T there. And then I need to provide it with the data. This data is used for calibration. If you use IntegraPose to generate your data file, YAML file on the first tab of the IntegraPose, it will look something like this. You don't have to do anything with it. Just provide the correct training image path and the validation image path. These two absolutely have to be spot on for the model to learn where these images are. So as it's compressing, it's doing a compression while having access to the original data. I'm going to give it this path. And last thing I'm going to do is set imgsc, which is the image size. Image size for my model training was 640. I left it as default, but here I'm specifying it because I don't want anything going wrong with my my setup. And the device is going to be device 0. That's the GPU number for my setup. And that should get this started. If you're missing anything in terms of libraries, it will auto update and install whatever it needs. And if the TensorRT is set up properly, it's going to move on to doing compressions and building the int8 engine. All right, guys, so the model has been exported and the quantized model is the int8 model. And now I'm ready to run the model. So go ahead and test out this model. This is a quantized model. So what I'm going to do is start with typing in YOLO, pose, track, the name of the model. Name of the model is this one, best.engine, and the source is going to be the video out here. I am not going to save this, so I'm going to set this one to false. Show is going to be true so that we can see in real time as the frames are getting run. And over here in the terminal, you will also see each frame's inference time go by. And we're expecting, or at least I'm expecting this to be in the 3 to 4 millisecond range, as opposed to 10 millisecond for the non-quantized model. So I'm going to press run on this. I'm not saving this. Okay, so that extra time that's required for saving the frames and the text files, that's not going to be influencing the inference time. All right, so here we go. I have clicked on this and I've paused it. So in the background on the right side, you notice all of these times on the right side of the video in the command terminal, they're all between 2 to 3 millisecond, 4 millisecond inference times for each frame. And that is the benefit of using the quantized version. So it gives us really a strong kind of a decrease in the speed and increase in the speed, but decrease in the time of the inference. I'm going to let this one run. I'm going to stop this for now. Max detect is going to be 1. So I have one animal. I'm going to set the max detect flag to be 1 so that extra things outside of the mouse are not going to get picked up. Rerunning this again. So this time only this mouse is going to get picked up. Those extra detections that were happening, those low confidence detections, are not going to get picked up. So again, look at the right side over there. This is doing behavior and pose estimation simultaneously. On my GPU, the timings per frame are between anywhere from 2.5 to, what is that, maximum there, maybe 4.2, something like that. Okay, so going to stop this one. Let's give the original model a try, which is called best.pt. So same thing, just going to run this with the original model. With the original model, the inference times over there on the right side, they're 10 to 17 milliseconds, 18 milliseconds per frame. Okay, so the quantization decreased or increased the speed, boosted the speed by quite a significant degree, and basically in terms of the confidence, in terms of prediction of the model, confidence didn't change that much at all. Okay, but do pay attention to the precision. If you need higher precision confidences, for example, or higher precision or localization of certain body parts, you are going to have to run the original model. If you're running this on for example, a CPU, having that high speed, smaller model is absolutely essential. Okay, so this is where I'm going to leave this video. That's how you do model quantization, YOLO model quantization. Hopefully this will help anybody who watches this video. Leave me a comment and give this video a thumbs up if you want to see more of this type of content. And thank you so much.